There is a star sitting in the shoulder of Orion right now that could one day turn night into day, cast shadows across your lawn at noon, and remain visible in the open sky for over a year. And most people have no idea that in 2027, something is about to happen to it that astronomers have been waiting on for decades. Betelgeuse sits about 650 light-years from Earth in the constellation Orion, and it is a red supergiant of extraordinary size, large enough to contain more than 400 million suns. Most videos stop there. They show you a big red circle, tell you it's going to explode someday, and move on. But here's what they're leaving out. Scientists just confirmed something that changes basically everything we thought we understood about this star. There is a hidden companion orbiting inside it right now. It has a name. It's leaving a physical wake through the star's atmosphere like a boat through water. And 2027 is the year the whole scientific community gets its next chance to see it. That's what this video is about. And I promise by the end, the thing you learn last is the one that nobody is talking about. Let's start with the size, because you need to feel this before anything else makes sense. If Betelgeuse were our sun, its atmosphere would extend all the way out to the asteroid belt. Think about that. Mercury, Venus, Earth, Mars, all of them gone, swallowed. If the companion star were standing on its surface looking outward, the red supergiant would fill nearly the entire sky. And the surface itself isn't some smooth, calm sphere. The Very Large Telescope has resolved actual patterns of light and dark across Betelgeuse's face, giant bubbles of hot plasma rising and falling, some of them larger than Earth's entire orbit around the Sun. This thing doesn't just sit there burning, it churns. It boils. It breathes. Its surface roils with slow 400-day pulsations, and riding on top of those beats is a second rhythm, a long secondary period of about 5.78 years. That astronomers long blamed on giant convection cells or dust clouds. For a long time, nobody could agree on what was causing that second cycle. And then in late 2019, things got very strange. From late 2019 to the beginning of 2020, Betelgeuse dimmed so sharply that experts thought the star was on the brink of exploding in a supernova. Since the event, called the Great Dimming, teams of astronomers determined that the star ejected a large dust cloud, which temporarily blocked some of its light from Earth's perspective. Headlines went everywhere. The internet decided Betelgeuse was about to blow. And here's the thing, the internet was wrong, but the story got even more interesting because of what happened next. After the Great Dimming, Betelgeuse didn't just go back to normal. Betelgeuse became brighter than we have ever seen it, having been promoted from the 10th brightest star in the sky to the 7th. It overcorrected. Then it dimmed again. And it has kept doing that, erratic, restless, behaving in ways that didn't fully fit any existing model. Scientists were tracking something real, something active, something they couldn't quite explain. And the explanation, when it finally came, was something nobody expected. Betelgeuse was not alone. A century-old hypothesis that Betelgeuse, the 10th brightest star in our night sky, is orbited by a very close companion star, was proved true by a team of astrophysicists led by a scientist at NASA's Ames Research Center. Until recently, astronomers believed it to be a single star. But in July 2005, a companion was announced based on observations in 2020 and 2024 using a specialized imaging instrument at the Gemini North Observatory. And here's what makes this one of the more remarkable detection stories in recent memory. Searches for the companion were initially made using space-based telescopes because observing through Earth's atmosphere can blur images of astronomical objects. But these efforts did not detect the companion. The Hubble Space Telescope looked. The Chandra X-ray Observatory looked. Both of them came up empty. The star was hiding in plain sight, completely invisible to the most powerful orbital instruments humanity has ever launched. A senior research scientist at NASA's Ames Center recognized that the ground-based Gemini North Telescope in Hawaii, paired with a special high-resolution camera built by NASA, had the potential to directly observe the close companion, despite atmospheric blurring. The advanced imaging camera worked by obtaining many thousands of short exposures to measure and remove atmospheric interference, providing a sharp image of Betelgeuse and its companion. The team detected the very faint companion star right where it was predicted to be, orbiting very close to the outer edge of Betelgeuse. Now here is the twist. Before this detection, the working assumption was that if a companion existed, it was probably a dead or dying star, a white dwarf, maybe a neutron star, something compact and old. Given the tentative detection, the team placed the star's mass between 1.4 and 2.0 solar masses, with the likeliest value being 1.6 solar masses. If the companion has the same age as Betelgeuse, this star would be on the cusp of joining the main sequence. A young star, roughly the size of our own Sun, still forming, still finding its footing, orbiting inside the atmosphere of a dying supergiant. And I want you to hold that image for a second, because what's happening to it is genuinely cinematic. This companion orbits Betelgeuse at a distance of about 4 astronomical units, not quite out to Jupiter in our solar system. Siwara is about 1.5 times the mass of the Sun and moves through Betelgeuse's atmosphere during its lengthy orbit. It's not orbiting around the star the way planets orbit our Sun, clean and clear in open space. It is so close to Betelgeuse that it is passing through the extended outer atmosphere of the supergiant. Every orbit, it plows through gas and plasma at a scale that dwarfs anything in our solar system. And as it does, it leaves something behind. Every 6 years, when the companion crosses between Betelgeuse and Earth, a trail becomes visible, and due to its density, it changes the spectrum of colors emitted by various elements in Betelgeuse's atmosphere. It's a bit like a boat moving through water, said lead researcher Andrea Dupree. The companion star creates a ripple effect in Betelgeuse's atmosphere that we can actually see in the data. As the companion moves through Betelgeuse's outer layers, it disrupts the surrounding gas, producing a trail of denser material. A wake, a literal plasma wake, carved by a sun-sized star plowing through the outer layers of a dying giant, detectable from 650 light-years away. Scientists identified 2 key cycles in Betelgeuse's variability: a 400-day cycle, now attributed to pulsations within the star, and a longer 2,100-day cycle, which had remained unexplained. This new study shows the longer cycle of variability matches the orbital period of the companion as it passes through Betelgeuse's atmosphere roughly every 6 years. So all those years of watching Betelgeuse pulse and dim and brighten, a huge chunk of that behavior wasn't a death rattle. It was the fingerprint of something hiding inside it. The companion now has a name. The traditional star name, Betelgeuse, derives from Arabic, meaning the hand of Al-Jawza, a female figure in old Arabian legend. Fittingly, the orbiting companion was named Siwarha, meaning her bracelet. It circles its host like a bracelet around a wrist, and right now it's on the far side. From Earth's perspective, Betelgeuse's companion is currently behind it, and therefore not visible. But astronomers are already planning new observations to coincide with Siwara's re-emergence in 2027, which will give them another chance to observe how it shapes Betelgeuse's atmosphere. That's the 2027 window. That's what the scientific community has circled on its calendar. Astronomers expect the next especially good opportunity to observe and study Siwarha to be in November 2027, when it will be at its widest apparent separation from Betelgeuse. Multiple teams are already planning campaigns to catch it the moment it clears the edge of the supergiant's glow. And I want to be clear about something, because this is where most science coverage drops the ball. The direct companion detection registered at only 1.5 sigma confidence, a tentative signal that still requires further validation. This isn't settled, done and dusted science delivered to you from a textbook. This is science happening in real time. Further detections will allow refinements to the orbit and thus give a better mass of Siwarha, helping to explain the evolution of the binary system, Betelgeuse's rapid rotation, and the future of the 2 stars. The 2027 observation window isn't just exciting, it's genuinely necessary. That's when the confirmation gets cleaner. That's when the picture gets sharper. So what does the future actually look like for this system? This is the part I told you was coming, and it's the part almost nobody is talking about. There will probably be a dramatic endgame for Siwarha. Tidal interactions are expected to pull the companion star inward, and it may be engulfed by Betelgeuse within about 10,000 years, long before Betelgeuse eventually goes supernova. 10,000 years sounds like forever, but in stellar terms, it's barely a breath. And when that merger happens, the consequences are not subtle. If the companion falls in, it could hurl several solar masses of hydrogen into space, setting the stage for an unusually bright interaction-powered supernova, potentially brighter than a quarter moon in Earth's sky. And that supernova, whenever it comes, whether from a merger or from Betelgeuse,